Hello, dear colleagues. My name is Svitlana Holoshchuk, and today I would like to present you the results of our research under the title Comparative Analysis of Using Different Parts of Speech in the Ukrainian Texts based on Stylistic Approach. This is the research performed by Alina Dmytriv, Lviv Polytechnic National University, Lyubomyr, Chyrun, Franko National University of Lviv, Roman Holoshchuk, Lviv Polytechnic National University, and Svitlana Holoshchuk, Lviv Polytechnic National University. The objectives of our paper are to analyze words of different parts of speech in Ukrainian texts to identify the speaker's purpose of using certain parts of speech to express his opinion fully. The next one is to present the software which analyzes Ukrainian texts and calculates the frequency of words of different parts of speech. To analyze the results of frequency comparison of other parts of speech based on texts of different styles, and to develop diagrams showing the statistics of obtained results. The object of the research is the analysis of the Ukrainian texts, which considers words of different parts of speech. The subject of the research is the study of the frequency and sequence of different parts of speech words in the Ukrainian texts. Recognition of Ukrainian language texts is only on the initial phase of its development. Modern investigations focus on developing available tools for Ukrainian language recognition. And modern programs developed for the analysis of the Ukrainian text do not cover the whole spectrum of the problems in the field. So the experimental basis of our research are the following software applications: Intelligent System of Ukrainian Text Processing, Large Electronic Dictionary of the Ukrainian Language, abbreviation is VESUM, Microservices Lang UK, Corpus of NER annotations, and a tonal dictionary of the Ukrainian language. Now let's move to a materials and method section and have a closer look at the developed diagram separately. On this slide, you can see a use case diagram which contains the following actors. User, it is a person who uses the system to analyze the Ukrainian text. VESUM, it is the electronic dictionary of the Ukrainian language, which contains word changes of the Ukrainian language, the register, the code of word change classes, and the rules for generating word forms based on these codes, and system database. So it is a created database for the developed system. Then this diagram contains the following use cases. The first one is analyze text, performs the primary function of the system. The user enters the text and begins to analyze the end text according to the following processes. Check the text language, checks the entered text, whether the text is written in Ukrainian. Tokenize, selects words from the entered text. Perform morphological analysis. The next one. A process that determines part of speech of all text words. Build sentence schemes. According to certain parts of speech, it builds schemes of all sentences in the ended text. Calculate the frequency of occurrence of parts of speech in sentence. The frequency of occurrence of grammatical conversion is calculated in each sentence separately, and then all the calculated frequency are summed. The next one is calculate the frequency of combinations of grammatical conversion. This is the frequency of combination is calculated in each sentence separately, and then all the calculated frequency are summed. Say everything in the system database. All the results of the calculated frequencies and constructed schemes are saved in the system database. Display the results of the analysis. Displays the obtained result, namely graphs of frequencies of parts of speech and frequencies of word combinations of grammatical conversion, as well as the most common sentence schemes in the text. Build graphs, here it is, design graphs of frequency occurrence of speech parts and frequencies of word combinations of different parts of speech based on obtained data from the system database, and get frequency results. Send a query to the database to get the calculated frequencies of different parts of speech and frequencies of word combinations of other parts of speech. And display sentence schemes. Identifies the most commonly used sentence schemes, which are built based on sentences from the entered text. Get constructed diagrams. Send a query to the database to obtain created diagrams of the text sentences. Now let's move to the next diagram. The next diagram is the stage diagram, which shows the main stages performed by the program to analyze different parts of speech and their position in the sentence. It also shows the transition of the system from one state to another state. On the next slide, you can see an activity diagram, which demonstrates the user's transition from one activity to another when using the system. To develop a system, we use the following tools: UI elements, Tkinter, MySQL database, and backend Python application. So the structure of the software contains the following files. Database.p includes all the necessary arrays of letters for morphological analysis. Wordinfo.p has functions for obtaining the basic morphological information, part of speech, word form, and its case. Table morphanalysis.p involves operations for creating a graphical interface with morphological analysis of words from the text. And wordFrequency.p contains functions for subtracting the frequencies of different parts of speech in the added text and building graphs for them. A developed program analyzes words of different parts of speech in Ukrainian texts. The program builds sentence schemes which represent the sequence of used parts of speech and displays a list of frequencies of occurrence of speech but in the text. Here you can see a Ukrainian text with an explanation of how the program analyzes it. So the Ukrainian text and the explanation how the program analyzes it. First, you enter the text in the field and then wait for the program to start it. The execution that might be long, as the program has to process an extensive number of words and build appropriate graphics. On this slide, it is presented the results of such processed text with the accurate morphological analysis of the Ukrainian words. It includes the following information: word, part of speech, word form, genus, syllabus, prefix, root, suffix, ending, letters, vowel, consonant, apostrophe, and hyphen. Based on the obtained information, we may develop the figures of the figure of different parts of speech in the text and figures of frequency of different parts of speech in a sentence. So here you can see frequency of different parts of speech used in the text, and below you can find different parts of speech used in each sentence separately. We have chosen 5 texts of different styles to test the program's analytics. They are publicistic, bell-letter, scientific, official, and conversational styles. The program calculates the frequency of parts of speech throughout the text and separately for each sentence. In its final stage, the results of all texts are compared. Diagrams for a publicistic text are presented here. So here it is the text, it is transcribed. This is the diagram of different parts of speech in a text. And here below, you can find each sentence modeled separately. The next diagrams are constructed in a similar way and are for the belly letters, scientific, official, and conversational texts and sentences within the text. So here you can see the belly letter style. Here you can find the text, its graphs for the official style. This slide shows us the conversational style, the text, the diagram of frequency of different parts of speech in a conversational text, and each sentence of the text is modeled here separately. Having analyzed the texts with the application of the program functionality, we built a line diagram that shows the frequency of different parts of speech used in texts of different styles. Its results demonstrate that the text of the conversational style has the highest number of the used parts of speech. Texts of other styles have the lowest number of verb use compared with conversational text. Instead, other parts of speech, such as nouns, adjectives, and prepositions, are often used. The frequency of verbs, numerals, and adverbs in these texts is about 0. So, conclusions. We have investigated the available analog systems, such as the Intelligent System of Ukrainian Text Processing, Large Electronic Dictionary of the Ukrainian Language, VESUM, Microservices, Lang UK, NER Annotation Corpus, and Tonal Dictionary of the Ukrainian Language, and applied their findings in our research. We constructed UML diagrams to represent the general purpose of the developed system, use case, states, and activities. Each diagram shows the system from different aspects to better understand its purpose processes. In addition, the basic functionality of the system is presented. As the implementation tool for creating a program to analyze Ukrainian texts, the Python programming language, MySQL database, and Tkinter graphical interface are chosen. The developed program builds sentence schemes and displays a list of frequencies of parts of speech in the text. In addition, it displays frequency graphs for the text and for each sentence separately, and also presents a morphological analysis of each word in the text. The obtained results are achieved through the analysis of using words of different parts of speech in the text of publicistic, belly letter, scientific, official, and conversational styles. That's everything which covers our research. Thanks for your attention.